let's tackle the question number 15. Question number 15. Alright, so this is question number 15, as we can see over here. They say the diagram shows a solid shape. The shape is a cone on top of a hemisphere. Okay, so as we can see, the shape is on top of hemisphere. So this is the shape, as we can see. This is the shape. Okay. The height of the cone is 10 centimeters. Okay, so that means these two things, meaning we're supposed to have certain formulas in our head. So with your level, the volume of a cone 1/3 pi r squared h has been given to us. So there's no need for you to memorize it. Likewise, the volume of a sphere is 4/3 pi r cubed. Okay, so the question is that the base of the cone has a diameter of 6 centimeters. The hemisphere has a diameter of 6 centimeters. And the total volume of the shape is K. So we know the total volume of the shape. Okay, so the total volume of the shape has been given to us to be K pi centimeters cubed. So that's the volume, V total. Alright, so you see, since we can see that the object given to us, let us try and draw it in a rough sense. The object given to us is a cone. Okay, a cone sitting on a sphere. Okay, like that. Okay, with a diameter of 6. So this, and it's got a height of 10 centimeters. Okay, so since they are together, our total volume, V total, is supposed to be the volume of the cone plus the volume of the hemisphere. The volume of the hemisphere, I'll call it H. So we know the cone VC has been given, we've been given a formula to be 1/3 pi r squared h. 1/3 pi r squared h. So that means we must be able to calculate the volume of the cone. So the volume of the cone VC will be 1/3 pi, the radius being, the diameter being 6, meaning radius is 3. Okay, so 3 squared. So that will be 3 squared. Okay, it's 3 squared multiplying by the height, which is VH, like that. So this H is 10. So if we simplify this we are going to get 1/3 pi times 9 times 10. Okay, this one cancels, so it goes here 3. So the answer to this is what? With 30 pi. So VC, this implies the volume of the cone is 30 pi. Alright, the hemisphere. The hemisphere also has a radius. The hemisphere has got a radius of 3. Alright, and we know that formula, we've been given the volume of a sphere. Okay, the volume of a sphere has been given to us to be 4 over 3 pi r squared. 4 over 3 pi r cubed. Pi r cubed. Okay, so if that is the case, this is the volume of, if this is a sphere, this is our sphere. Okay, when we divide it by 2, okay, will be the hemisphere. So meaning the volume of hemisphere, okay, VH, should be half multiplying the volume of the sphere, r cubed. So this will give us, when we simplify this multiplying, so we're going to get 2 over 3 pi r cubed. Then we know the radius, we know the diameter as well to be 6. So therefore our radius is 3. So when we substitute, we get the volume of the hemisphere to be 2 over 3 multiplying 3 cubed. And we know when we multiply 3 cubed, we get 27. So this will be 2 over 3 pi times 27. Okay, if we are right, r cubed is 927. 3 goes here, 3 goes itself, goes here 1, and goes here 3. To multiply by that, okay, pi r cubed 3. So let's see, we have pi r cubed. What, we haven't done anything wrong? Okay. Okay, so our volume, so pi r cubed, that is 6 hemispheres, it's just that. Okay, so what do we get? We have 4 over 3 for pi r is 6. Okay, so when we do that, what do we get? So this goes here 3 times 2. So then that's the radius, this pi r cubed 2 over 3 pi 27. Okay, we have our radius, this to be that. Okay, let's see, pi r cubed. Let me just get the question very well. Okay, 2 over 3, 9. Okay, so we'll be left with 2 pi times 9, and that will give us 18 pi. Okay, since we know the V, he said we should find the total volume of the ship is K, where we should find the value of K. So since now we know K pi, there our K pi is equals to 18 pi plus 30 pi. So this will give us 48 pi. 48 pi and this K pi. So pi will cancel each other, and our K will be 48. Well, so that is the answer for question number 15. And look for question. Yeah. Question number, let me see, question number 15, we've done it. Look for question number. I've done this. Question number 16. Okay, question number 16. Question number 16. All right. Question number 16. All right, that's what we have. Question number 16. Okay, there's the question. It said there are 3 dials on a combination lock. There are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4, 5. The 3-digit numbers or 3-digit number 553, as you can see it over here, 553. Okay, so 553 is one way the dial can be set, as shown in the diagram. Work out the number of different 3-digit numbers that can be set for the combination. You see, so our possibilities. You see, the possibilities, since we have, look at it, we have 5. Okay, we have 5. Clean this. So 3 possibilities. All right. 3 possibilities. So let's clean this one in the meantime, and we'll come here. 3 possibilities. Okay. All right. So there are 3 possibilities. As you can see, there are 3-digit numbers. 553 is one way dial. Okay, so let's take that one. We know we're 16. Okay, so 3 possibilities. 3 possibilities. We have this first one given us 5, 5, 5, 3 according to the diagram. So meaning that the possibility, the other possibilities is by the thing being 5, 5, 5, because we're given that the numbers ranges from 1, 2, 3, 4, 5 combinations, as you can see. So that means if we take from what we see on a diagram, from what we see in the diagram, you see, when we take the numbers given here, you see we have 553. So the possibility is either 5 on 5, or 4 on 5, or 3 on 5, or 1 on 5. You see, that's all possibilities. So then, to be able to find the actual, okay, that's what we do. Okay, so what is it? So 16. Okay, so let's look at all possibilities. So we have 5. Okay, so we're here. Let me draw the thing very interesting, the way this thing cannot draw properly. So this is the log, and we have this on top of it. Okay, the possibility is this. We'll be given this one as 5. Okay, and this one also pop out here to be 5, And the one here that pop out here is also 5. So the possibilities is this one can be 5, 5, or 5, because in a nutshell, the outcome, the total outcome is 5. So 1, 2, 3, 4, 5 are all possibilities. So if we know that the sample space is 5 by 5, then we will say that by product rule, yeah, the outcome, the product rule. So we see A by the product rule, the outcome will be 5 multiplied by 5 by 5 by 5. Okay, and this will give us 125. Okay, so that is what that one will give us. Now let's look at the other part of the question. It says work out the different numbers that can be set for combination. And the B part says, what does it say over here? Okay, so the B part, yeah, will be the likelihood will be 5 by 4 by 3. Okay, and this will give us 20 times 3, which is 60. So that is all the necessary possibility. Let's look at question number 17. All right, question 17. Okay, that's what question 17 says. All right, question 17. Right, it says given that x squared dot 3x plus 5 is equals to 1 dot 2. Find the possible values of x. So we've been given there. We have x squared dot 3x plus 5 is equals to 1:2 ratio, and we're supposed to find the possible values of x. So this, it actually means that x squared over 3x plus 5 is equals to 1/2. Okay, so we cross multiple. Okay, we cross multiple. This examination time is very small, so you cross multiple. Cross multiply. Then this will be 2 out and 1 out. Okay, so when we cross multiple, we get 3x plus 5, and 2 is multiplying x squared. So when we do the expansion, we get 2x squared is equal to 3x plus 5. Okay, so let us rearrange, and then this will be 2x squared minus 3x minus 5 is equal to 0. So what comes into your mind? As quadratic, as quadratic in x. So we'll find the possible values of x. That makes the ratio exist. So this one, when you multiply this by that, we know our factors. The factors are 2 times -5. Okay, so when we convert this in x, okay, this will be 2x minus 5x. That's what we're going to substitute over here in place of -3. So this implies that 2x squared plus 2x minus 3x, yeah, 5x minus 5 is equal to 0. All right? So we do factorization here. So this implies 2x out, x plus 1 is in this minus 5 out, x plus 1 is equal to 0. Quadratic. We always know that there's supposed to be multiplicity somewhere. So that is it. Similar one. This implies that our equation will be 2x minus 5 or x plus 1 is equal to 0. So we say 2x minus 5 is equal to 0 or x plus 1 is equal to 0. And this implies that 2x equals to 5 implies that x is equal to 5 over 2. Okay, and x plus 1 is equal to 0. Meaning this implies s equals to what? Negative 1. Okay, so the question says find the, let's go back again to realize what we have. Question number 17. Yeah, that's what it says. So find the possible values of x. Yeah, so these are the possible values of x. Yeah, for the full mark. Let's tackle question 18. Yeah, so this is, let me take you through a bit. This one, that's the ratio. So we wrote this one like this. And this is equals to what? 1. Okay. 1 over 2. We will cross multiply. Okay, so this 2 multiplying this 2 multiplied the s squared. So we have it here. And 3s plus 1 multiply 1. Okay. Then after that, we rearrange the equation. Then we had quadratic equation in x. Okay, we know here, negative 3, we have to find the factors that will make it possible to be able to factorize. And that is 2 times negative 2 for negative 5. That gives a negative, yeah? Now when we change the sign here, plus and minus, this will become 2s minus 5. That gives us the factors. We substitute the factors back into the equation, okay? And here we are. We have been able to solve the question, yeah? So that is this easy quadratic equation. So let's look at question number 18. What is it? Question 18. Good. Question 18. That's what we have. Let's look at it again, friends. That is it. That is it. Okay, this question number. This is question 18. 18. That's what I've been given. This is it 3? Yeah, question 18. Let me look at the right one. The paper is a bit dented. Alright, that's question 18. This is what we have been given. It said express root 3 plus root 12 in the form a root 3, where a is the examination condition. You must be able to solve this question on time. The B part is express 1 over the square root of 3 with the power 7 in the form of square root of b over c, where b and c are integers. So straightforward, what do? This is root 3. Let's work some set. Root 3 plus root 12. So straight on, we know that this, we can break it. Yeah, we say root 4 times 3. And we can further break this one down. We say root 4 times root 3. And we know this will give us 2. So 2 root 3 plus our root 3. Okay, what do? We can factorize. Okay, so we can say 1 plus 2 into bracket root 3. And that will give us 3 root 3. That is the answer expected. So that's a root 3. We are able to do it. Yeah, it says what? Yes, where a is an integer. So a is what? Equals to 3. The integer. Okay, the last bit says express 1 over root 3. 1 over root 3. Express 1 over root 3 into bracket 7 as the way it's been given. So this, or what you have to do, that the 1 always stand. this can be written as 1 raised to the power 7 over root 3 raised to the power 7. So you know for sure that root 7 means we have root 3 times 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 root 3. So how many do we have? 1, 2, 3, 4, 5, 6. We need a 7th one. Okay. So if that is the case, okay, so we have this, we can multiply this. This one will give us 3. Multiplying this one will give us 3. And this multiplying this one will give us 3 times root 3. So in effect, this multiply by that. Then 3, 9, 27. Okay. So 27. Yeah, 27. This 27 root 3. Okay, becomes the answer. 27 root 3. 9. Okay, and so what can we say? What can we say? Now, this is what we have. But so our answer now becomes 1 over 27 root 3. But this is not what we expect to, get. Because we've been asked to put it in the form root B over C. Our expression is supposed to be root B over C, meaning we need to rationalize. So we say by rationalization, or by rationalizing this. Okay, so we have 1 over 27 root 3. So you multiply root 3 here and root 3 here, you have rationalized it. So you know when you multiply this and that, you get 3. So meaning our value will be 1 over 27 times 3 root 3. And we know that this 3 times 27 is 81. So root 3 over 81. Okay, so this is what examiner wants us to do. So as you can see, it says where B and C are integers. Yes, so B and C are integers. So we're done with question number 18. Let's go and tackle question number 19 as well. Let's see how beautiful we gradually getting closer. Okay, so question number 19 is that's what we have over here. Yes, question number 19. Let's expand it as usual to be able to see it in big. All right, so that's how, and that's what we have. Okay, for question 19. Question 19, let's place it well so we can see it properly. All right, so given that x squared minus 6x plus 1 is equals to x squared minus a plus squared of that minus b for all values of x, find the values of a and the value of b. Find the value of a and the value of b. All right. And the last part is hence write down the coordinates of the turning point of the graph. Okay. So let's tackle the question. Okay. We have been given that word x squared minus 6x plus 1 is equals to x minus a squared minus b, and we are demanded to find the values of a and b first, then find the turning points of the graph. Okay, so if that is the case, let's look at this. Well, this one, when we expand the right hand one, so we say x squared minus 6x plus 1. This one will be x minus a minus b. Okay, and this will give us x squared minus 2ax plus a squared minus b. Okay, so this x squared minus 6x plus 1. Yeah, this is our left hand side and the right hand side. So we say by inspection. Okay, why do we say by inspection? By inspection, we will see that if you look at it very carefully, okay, you will see that minus 2as is equals to negative 6x. And also our a squared minus b is equals to 1. So we have equation 1 and equation 2. So we say from equation 1, we have 2ax equals to 6x. So the x cancel. So that we have 2a equals to 6. Therefore, a is equals to 3. Okay. So after getting the value of a, we'll substitute a is equals to 3 in equation 2. So our equation 2 is given as a squared minus b. A squared minus b is equals to 1. Oh, beautiful. So now we know b. So a squared, so that'll be 3 squared minus b is equals to 1. And this will be 9 minus b is equals to 1. Okay, so when we do that, negative b is equals to 1 minus 9. So our b is equals to 8. So now we know the values of a and b. That's what we were demanded. Then the last part is hence write down the coordinate of the turning point of the graph. Okay, so now all what we have to do, we have to substitute back the values. Yeah, so we know that this equation, which is y is equals to s squared minus 6x plus 1. Y is equals to s squared minus 6x plus 1 is equals to the equation given a minus b squared. Yeah, a minus b squared minus x minus a, so minus b squared. So this x minus a is x. Okay, x minus a squared b. So that is x minus a squared b, x minus a squared b. So when we put the equation back, this is the same as saying that since we know the values, x minus a, our a as we calculated was 3, and the b was 8. Okay, squared. So meaning here we can say that x minus 3 is equals to 0 is the value of 10x, the turning point on the y on the x-axis, and the y-axis is equals to, this is 3 minus 0, sorry, the 3, yeah, this is 3, so it's equals to 3, and the y is equals to negative 8. So the turning point, therefore, the turning point 3, negative 8. We're done with question number 19. So let's go back to it again. So that's all what we're given. We're given that x squared minus 6x plus 1. Okay, we're given that x squared minus 6x plus 1 is equal to x minus a squared minus b. Okay, find the values of a and b. This is what we're looking for. So our a, and later on when we calculate it, we had the value of a, okay, to be 3. Okay, our value of a was 3. Okay, value of a, when we had it to be 3. Value of a was 3. And that is negative 8. Alright. So when we look at it, all what we did was expanded to the right hand one, and we have s squared minus 2s plus a squared minus b. So by inspection, we know this minus 6s is the same as negative 2ax. So negative 2ax. So from that, we also realize that a squared minus b, this standalone, is equals to 1. Okay, so we made change of subject and we had our value of a to be 3. Okay, then after that we substituted it into the equation and we had a value of b to be 8. Then this equation, eventually we substituted the values back to the equation here, and note this is method of completing the square. You see, if you look at it, it's a method of completing the square. And anytime you are doing method of completing the square, when you have x minus 3 raised to the power 2 minus 8, meaning x minus 3 should be equal to 0. So the x will be 3 and y is equal to negative 8. That is the turning point of the equation. Okay, let's see question 20. Question 20. Okay, let's look at it. Question 20. Question 20. Let's place it well. Question 20. Alright, that's all we have. Okay, so this is the question 20. They say h is inversely proportional to p. Okay, and p is directly proportional to t. Given that h is equal to 10 and t is 144, when p is equal to 6, find the formula for h in terms of t. This is straightforward. So h is proportional to p. So we write our formula. We say h is proportional to p. That's one expression. Second one says p is inversely. Oh, let's look at it very well. Say h is inversely proportional to p. So that means h is inversely proportional to p, 1 over p. So one expression. And p is directly proportional to square root of t. So p is directly proportional to square root of t. Okay, so this is equation 2. So we are able to identify our equations. Okay, but we have been given certain values. Okay, let's say h is 10. T is 144 and P is 6. Okay, so from the two equations that we have to remove the proportionality sign. So if we start from the h, the first one. So from 1, we can say that h is equal to k over p. Okay, so we have to find the value of k so that we're able to establish that particular equation. But we have been given that h is equal to 10, so we put 10 here. Is equal to k over p, and p is 6. So divided by 1, this means I'm going to get 1 times k is equal to 6 times 10. Okay, so k is now 60. So I've been able to establish that equation which says h is equal to 1 over p. Now we can say that h is equal to 60 over p. So that becomes our equation 3. Okay, now let's look at p as well. P, we can say p is equals to k root t. Root t. So lo and behold, we have the values of p as well. Okay, and we have values for, we have t as well. So t, we can say that p now is equals to k square root of 144. So we know 144 gives us 12. So p is now equal to 12k. All right. And the question says, find the formula of h in terms of t. So now, looking at our equation number 4, okay, to that of these two equations. Okay, let's look at it. These two equations, this and that, will help us to be able to deduce, since we know the value of P. Okay, so in terms of H, this one means H is equal to 60 multiplying 1 over P. Okay, and the P is equal to 2K. So H now is equal to 60 times 1 over 12K. So the question says, find the formula, make a formula of H, and T. You see, formula of H in terms of T. So now that's where we're going. Yeah, in terms of what T. Let me see. K, T. All right, in terms of T. So now we know K. The value of K will be P over 12. Yeah. So now we know K. Over here, we can also remove, when we come here, we can, since we know this, K, the value of K over here, it will be so straight on. So we have H to be 60 over P, and that will help us to eliminate. So we have P is equal to KT. So we have to remove the P out of our way. Okay, if we have to move the P out of our way, then we have HP. HP is equal to 12K. Now we know the K, we have value of K, and the K is that. Okay, so let's substitute. Let's write our equations one by one. So 1 of the K over here, then we have to find the value of K to be able to, so this equation over here, so I've written over here, you see, so H is equal to 60 times 1 over that. So we have to find the K itself. Okay, P that 1 over K from that. Then we have P is equal to K square root of T. P is equal to K square root of T. So that P is equal to K square root of T. So making K the subject, from here we can say K is equal to P over root T. You see, K, so that this will be H equals to 12, 60 over 12K. Let's give us 5 goes here. So let multiply it. Okay, let's say this is 60 over 12 times 1 over K. Now we know K. So 60 over 12 times 1 over K. So 1 over K, so 1 over P square root of T. Okay, so this one will turn. So we have 60 over 12 times square root of T over P. Okay, that goes to H. Now, let's see. 60. So we have 60 divided so we have 5. So the equation now, because the H is equal to 5 instead root of T over P, so that is what we have. So that is what we have. So you see, make, yes, H in terms of T. Well, we know P is equal to 6 even as well in terms of T. So 1 P is 6. P is 6. So H will be equals to 5 root T over 6. So this is a change of subject. Well, friends, this is straight on. Now let's go and tackle question number 21. All right, 21. 21. This is the question given. 21. Okay. We have been given the function f. Okay, let me clean it before I start the study. Okay, so the function f and the function g are such that f of x is given as 3x minus 1 and the g of x is equal to x squared plus 4. Find the f inverse of x. Okay, so let's tackle that. Of f. So f of x has been given as 3x minus 1. They say we should find the f inverse of x. So say let y is equal to f of x. So this implies that y equals to 3x minus 1. Okay, well, our purpose here is to make the x the subject. Okay, so if that was the case, we'll say y plus 1 is equal to 3x. And implies that this implies that x is equal to y plus 1 over 3. So to find the inverse of the function, we say interchange the values of the values of x and y. So this implies this will be equal to y is equal to x plus 1 over 3. So therefore, the f inverse of x is given as x plus 1 over 3. All right. So that is how we find the inverse of x. Okay. Now the question says that given that f g of x is equal to 2g f of x. So let's see. Question, last part, B. So show that 15x squared minus 12x minus 1 is equal to 0. Given that f g of x is given as 2g f of x, show that 15x squared minus 12x minus 1 is equal to 0. So that means after computing this, we should be able to prove that. So let's see. F g of x. F g of x is equals to 2 g f of x. 2g f of x. 2g f of x. All right. So let's look at it. Fg of x, Fg of x, and 2g of x. All right, and we know f of x is given as 3x minus 1, and g of x is given as x squared plus 4. So we have to calculate for f of g of x. F g of x means taking f and putting a g. So f is there, you put in a g. So this will be 3 into bracket x squared plus 4 minus 1. Okay, you understand? So the f is there and the g is coming to stay in. So f is there. So that will give us 3x squared plus 12 minus 1. And that our answer will be 3x squared, okay, plus 11, if I'm right. So 3x squared, yeah, plus 12 minus 1, and that is 11. Okay, so now let's look at j standing there, f of x, means j is there, and f is entering. So this is s squared. So in this case, it's going to be 3x minus 1. Let me clean this one. okay, it's going to be, okay, so J is there and the F is entering. So J, which is, so this is going to be 3x minus 1 squared plus 4. Okay, so we know this one is expanded. 3x minus 1, 3x minus 1. This is show your all your procedures. So this will be 9x squared minus 6x plus 1 plus 4. So 9x squared minus 6x plus 1 plus. So this will be 9x squared minus 6x plus 5. And they said this, you should equate this and that. This and that. And so if that is the case, we say that 3x squared plus 11 is equal to 2 times that, 9x squared minus 6x plus 5. Okay, so 3x squared plus 11 is equal to 18x squared minus 12x plus 10. Okay, so let's rearrange. When we rearrange, we are going to get 18x squared minus 3x squared, yeah, minus 12x plus 10 is there already, and then minus 11 is equal to 0. So let's see. So this implies that 18 minus that. What we're supposed to prove that this is 15 squared minus 12x plus 1. We have done that. So let's look at it. So this will be 15x squared minus 12x. 10 minus 11 will be minus 1. Is equal to 0. So that is it. Hence the proof. Hence the proof. Right. So question, this is self-explanatory. So I think when you go through it properly, step by step, you'll be able to, assimilate and digest it properly. All right. So this and that, that's what we get. All right. Question number 22. Good. Question number 22. What's the question? Question 22. Where is it? Okay, that's question number 22. Beautiful. Question number 22. Question number, let me put it down here. Compare it to that. Maybe I didn't scan it. Oh, I just scanned it. Did I scan this? Alright, I did. Okay. Alright, so let's look at the question very carefully. There's the last question. The last and not the least. Alright. Okay. Look at the question given. They said there are only red counters and green counters in a bag. A counter is taken at random from the bag. You see, so we have only red and green counters in a bag. And a counter is taken at random from the bag. The probability that the counter is green is 3/7. Okay, 3/7. And the counter is put back in the bag. The counter itself is put back in the bag. 2 red counters and 3 more green counters are put in the bag. You see, are put in the bag. A counter is taken at random from the bag. The probability that the counter is green is also 6/13. Find the number of red counters and the number of green counters that were in the bag originally. Okay, so if you follow the question, you see that there are more. So there are 2 more red counters. Okay, so straightforward. we say that when, let's say, let's begin to solve the question. So we say let the counter taken at random. See, note that counter taken at random. Okay, counter taken at random. Let's bear that in mind. Okay, so the counter taken at random. Okay, and so what we have is we have red. You say only red. So only red. Only red. So we let this one be our red, and green. And you see, only red and only green. Only red. Only red. So I want to use my colors to symbolize what I'm doing. So green counters. So only red counters and only green counters. So we have green counter. Okay, so all green count. We have green counter. So green. Yeah, counters. Red counters, green counters. So this will be my green. Okay. So find the number of red counters. Yeah. So if I look at the pick one, okay, pick one. If I look at pick one, if I have red and green, then my total, okay, in the bag, total will be red and green. Red, okay, and green. And green. So that would be total in the bag. Okay, this is what I have in the bag. Okay. So there are two selections. So the first selection, probability of selecting green should be equal to number of green counters. Number of green counters divided by total. Okay, number of green counters by total. So if that is the case, probability of that green counter will be green counter all over the total, which is R plus G. But we've been given that probability is 3/7. So I'll call this one my equation 1. So this is the first pick. First pick. Okay. So let me put it here. First pick. Pick 1. Okay, now let me talk about pick 2. Pick 2. That pick 2 says that there were multiple. See, 2 more reds. 2 more reds counters and 3 more green counters. Okay, so with this, okay, what is happening? With this, you will see that originally, if there are 2 more of the red and 2 more of the green, then our second pick, the total, okay, the total for the second pick will be red 2 more and a green 3 more. So this equation will be R plus G plus 5. So that will be total. Okay. Now, the question says I should look at the question once more. It says find the number of red counters and that of the green counters. So the probability of the green counter is 6/13. So the green, 3 more of the green. So that will be green plus 3. The probability of green. Okay, look at it very carefully here. Here it will be that tray selected all over the total, which is R plus J plus 5 equals to 6/13. Okay, now let's call this one equation 2. So what we have to do after being able to create such a thing is to solve them simultaneously. So our simultaneous equation, if you look at it very carefully, okay, let's look at how best and a quick way it will help us to solve the simultaneous equation. What's the question? Okay, last part of the question. Let's see. Yeah. So the last part of the question, as it says, find the number of red counters and the number of green counters that were in the pack originally. So you see, taking 3 more of the greens, he's talking about the greens, taking 3 more of the greens, meaning from my equation 1, I can say that 7G, let me put it here, equation 1 is J over RG, J over R plus J is equal to 3/7. R plus J is equal to 3/7. So I would say this implies that 7G is equal to 3 into bracket R plus J. Okay, and if that is the case, the other one too, I can say 13 out, J plus 3 is equals to 6 into bracket R plus J plus 5. Okay, so this has been our equation 3 and equation 4. Okay, so by inspection, you see that we can see that from here, from 3, we can see that R plus G is equal to 7G over 3. Then we substitute this as 5, put 5 in 4, so that we have 13 out, J plus 3 into bracket is equal to 6, 7J over 3 plus 3 plus 5. Okay, so when we simplify, we are going to get 13J plus 39 is equals to 3 cancel these 2, so this will be 14G plus 30. Okay, so all the G's come out. So 13G minus 4G is equal to 30 minus 39. Okay, so negative G is equal to negative 9, implying that G is what? 9. Okay, so we are able to find that. Well, we can also use the same one to find for the red as well. So when we substitute 9 back into the equation 5, well, we say that 4 times 9, okay, all over 3 is equals to R plus 9. Okay, so this means this will cancel this. So we are going to get 3 will go into 9 3 times. Yeah. So 9, it goes there. We have a 9 over here as well. So what do we get? 4, 3 goes here, 3 times, that should be 12. This goes R plus G. So that when we cancel, we get 21. Let me cancel it. What's the formula? R times G, 7. R plus times G over 7. Reduce. So R plus G, we have 9. So 9 plus R, okay. Then we have 7 G over 3. 7 G over 3. So 7 G over 3. 7 G over 3. 7 G over 3. Okay. So 7 G over 3. 7 G. This is 7. Okay. 7 G over 3. So this goes here. Okay, so step by step, and with your level, you must always show the step. You don't assume. So this will be 21 over 3. This goes R plus 9. Okay, and then 3 goes into 7. How many times? 3, 9, 21, 7. This goes R plus G. So RG, okay, so 9, 21, so 9, so 21, RG. So what do we do? How do we get R? Okay, so R will be equals to 12 minus 9. So the red will give us 21 minus 9. 21 minus 9. 21 minus 9. 21 minus 9. What do we get? We get 12. 9, 12. Okay. So therefore, R is 12, G is 9. R is 12, and so the number of reds, so R is 12, and G is 9. So these are the numbers of green counters and the red counters in the bag. Yes, friends, this has been so beautiful. I know it's been smart, fast, quick, speed, or whatever you want to call it, but at the end of the day, it's an examination, so we got to work with the speed of time. Well, friends, nice having you around. Please enjoy your day, and COVID is rare. Wear the mask and stay a distance apart. Please subscribe, and see you around again. Have a nice day. Bye.